Whenever we make a measurement, there's 3 simple steps to make a measurement to make sure that our measurement has the appropriate number of significant figures. All of this is based off of the value of the instrument as well as the precision. So how many lines there are can help us to determine the quantity of significant figures. So our first step, we need to figure out what is the smallest degree of measurement. After we do that, we're going to make the measurement to the smallest known degree and then estimate the last digit of measurement. In every measurement, you need to have known digits and estimated. Every single measurement you make is going to at least have the one estimated digit. Known digits, it depends on the quality and precision of your measuring device. So in the first example here, I have a ruler, and I'm going to zoom in to make it a little bit easier to see it. So we're measuring the length of this line. So taking a look at this ruler, the small lines represent a millimeter, while the large lines represent centimeters. But if we want to write them together, the 2, for example, would represent 20 millimeters. So the known degree here, or the known measurement, is where we can see the measurement in terms of the lines. What line are we for sure knowing that the line is longer than it? So we know for sure it's past the 20 line because we're measuring in millimeters. It's also past this very first line. So 21 is my known measurement. There's no doubt that those are known values. Then we need to estimate one digit. So in this problem, it's going to end up being the 10th place because we're measuring in millimeters. So whenever we're estimating a digit, there's going to be some matter of opinion. So our answers might vary slightly depending upon how high of a quality of the measuring device is and how clear of a picture or how small it is. So there is going to be some range here, and that's acceptable. So if you take a look at the line, it goes about halfway in between the 1 and the 2. So I would say 21.5. Now, if you think that it doesn't quite go to the 0.5 and you said 0.4, that's fine, or 0.6, that's fine as well. Usually when you're estimating a digit, there is some range of error there depending upon how high of a quality device you're measuring with. So 21.5 would be what I would say. But as long as you're pretty close, so 21.4, 21.6, all of those would be considered acceptable. The big thing here is that you're not going beyond that. You could not say 21.56. You can't have another estimated digit. You can only have one estimated digit. Notice you could also make the measure in centimeters. You're just moving the decimal. Your known digits and estimated digits aren't changing. You're just changing the overall decimal location because you're changing the magnitude of the size of the measurement. In the next example here, we have a very, very small line that we're measuring in millimeters. So this ruler doesn't give us a lot of information. We know the only known value here is the 3. The 3 is known because at minimum this line is longer than 3. So we have one known digit in this case. We can only have one estimated digit. So for this value, I would probably say 3.7. 3.8 would also be acceptable. The big thing here is you only have one estimated digit, and that's your 7 or your 8. Both would be considered accurate. You have to be you're using the device that's provided to you. So if you aren't given a good device, it's very difficult to get a very precise answer. So if we were to continue to use this in a calculation, we could only have those 2 significant digits. So let's say, for example, these two measurements were connected. So what we're going to do is we want to measure the surface area. So we have 3.7 millimeters times 21.5 millimeters. So if we're multiplying these together, Multiplying goes by quantity. We'll have 3 sig figs times 2 sig figs, which will result in my answer having 2 sig figs. So why don't you calculate that and see what you get? So your calculator gave you 79.55. However, we can't keep that many digits, so we would keep 2. Looking at the 9 with the 5 would have to be rounded up. So it'd end up being 80 with a decimal point millimeters squared. Because we're multiplying units, we end up with the squared value, which is a little bit different than in addition and subtraction. Taking a look at the temperature here, which we're measuring in degrees Celsius, we have known degrees and we have estimated degrees. Now, this one is a little bit trickier because we don't have a line representing 1. Sometimes this happens, your measuring device goes by 2s or goes by 5s, whatever it may be. If the measuring device doesn't go by 1s, you can't count it as a known digit. So for example, here we are clearly past 70, so the 70, that's really our known digit. So what we're going to end up with, this one's pretty clearly between 72 and 74. So this one's going to be 73 degrees Celsius. That the 3 is going to be the estimated digit, because there's no way with this measuring device to know for sure if it is 22.5 or 22.9. We don't have the information with our thermometer. So depending upon the measuring device you have will determine the quantity of significant figures you have.